Here we are in section 5-4, exercises 5 through 16, and all sorts of factoring going on here. So here's this microcosm of the chart to make sure that we can pick which method is going to happen with which one. They will all start with greatest common factor. First and foremost, we got to try that. Then if they have 4 terms, we'll group them. If they have 2 terms, we're looking for a perfect squares or perfect cubes. And if they have 3 terms, we look for their leading coefficient, see if it's a perfect square or the AC method. All right, that was a quick summary. Let's go through them. Number 5, is there a greatest common factor? No, there's not. How many terms? 1, 2, 3. Leading coefficient equals to 1, so this is going to break up quickly in one step. We just need to look at the last one, 12. Okay, we know that we're going to have an x and an x. And what multiplies to 12? 1 and 12, 2 and 6, 3 and 4. Do any of those add to 7? And that one does right there, so it's a plus 3 and a plus 4. And if you multiply that all out, the middle terms will be a 3x and a 4x, and it will work. Number 6. Okay, is there a greatest common factor? This is 3 times 3 times 3 and 7 times 7 times 7. So nope, no common factor there. How many terms? 2. Is it a difference of squares? Nope, 27 is not a perfect square. It is a difference of cubes. So we need to identify that this is 3x cubed and this is 7 cubed. So that gives us our 3x and our 7. So the pattern on difference of cubes was 3x minus 7 because we want to end up with a negative 343. And then this squared, so that's 9x squared. And at the very end, we're going to have a plus 49 plus 7 squared. And that'll make a perfect cube, perfect cube. And in the middle, we need to have the opposite sign plus those two times together, 21x. So that was the pattern for a difference of cubes. All right, number 7. Is there a greatest common factor? I'm going to highlight that just a little bit more. Do we have a greatest common factor? We don't. How many terms? 3. The leading coefficient is equal to 1, so we're going to be a short one here with a negative 24 out here. We could have a 1 and a 24, a 2 and a 12, a 3 and an 8, or a 4 and a 6. Okay, good. And it's a negative 24, so we're talking about things that subtract to, one of these has to be negative, so they'll subtract to 10. Notice it's not going to be a negative 4 and a negative 6. That would times to a positive 24, so that is not the magic pair. It's that one, 2 and a negative 12. So it's got to be x plus 2, x minus 12. Multiplying to a negative 24, adding to a negative 10. Excellent. Next one, number 8. Is there any greatest common factor? No, that's a's and that's 8. All right, how many terms? 2. So we're looking for either a difference of squares or a sum or difference of cubes. This is a sum with a plus sign in here. And so we look and yes, this indeed is 2 cubed and that's a cubed. So we're going to be doing a sum of cubes. So the formula for that is we would take the first factor is a plus b, which is, 2 in this case. There's the 2 cubed right there. And then the second one is a squared. That'll give us an a cubed when we times them. And a plus 2 squared. That'll give us an 8 when we times them. And the secret ingredient is the minus 2a, the opposite sign of that times that right there. And yeah, if you multiply all this out, all of those 4 middle terms will cancel and you'll be left with a cubed plus 8. That's the pattern for a sum of cubes. All right, number 9. 10x squared minus 2x minus 72. Is there a greatest common factor? Yes, there is. We can pull a 2 way out front here. We're left with 5x squared minus 11x minus 36. At least a little bit. That got us to smaller numbers. Okay, so now what's left? Are there 2, 3, or 4 terms? There are 3 terms. And if we go down here, the leading coefficient is a. It's not equal to 1, so it's ax squared. Just double check really quick. Is it a perfect square? No, 5 is not a perfect square. Even though 36 looks not promising, it's not a perfect square. So we can't do that. So we will have to do this AC method, where you take A times C. 5 times 36 is negative 180. Now we have to find the pair of factors of 180 that add to negative 11. So let's go through them. 1 and 180. 2 and 90. 3 goes into 18 6 times. 4, so half of 90 would be 45. 5 goes into that 36 times. That's how we got it. That was good. 6 goes into it 30 times. Oh boy. 7, nope. 8, nope. 9, go into it 20 times. 10 would go into it 18 times. 12 goes into it 15 times, and I think that's about all of them. Wow, that's a huge long list. Now this is a negative number, so we'd have to, when adding, it's actually subtracting. So let's put this negative on here because we're going to end up negative. So the larger one, when we add two numbers, has to be negative. And anything here, add to or subtract the absolute values of them. 2 and 11. 31. 24, 20 minus, there it is. There's the 11 right there. It takes some work. Go ahead and be patient and to find those, this subtracts to 8, that subtracts to 3. There's our 11. That's our magic one right there. So this guy actually came from a 9x and a negative 20x. Whoa, great bit of sleuthing right here. Okay, so I'm going to ignore this 2 for a little while and he'll show up at the bottom. We now have the AC method. Once you split A times C, split B, you now have how many terms? 4 terms, which is why this arrow goes up here to grouping. So let's chop it in half. And out of the front, we can pull an X. And what are we left with after we pull the X out? 5x plus 9. All right, what can we pull out of the back half here? Certainly a minus sign. And what goes into 20 and 36? If it's hard to see, we're trying to end up with a 5x. So we better pull out a minus 4. And that will allow us to get a, oh good, there it is, the 5x plus, because we pulled out a negative 4, 9. All right, so that gives us, pull out that 5x plus 9 out front, 5x plus 9. And we're left with x minus 4. And this 2 is still part of the whole program here. So 2 times 5x minus 9 times x minus 4, if you multiply all that out, you'll end up with 10x squared minus 22x minus 72. Wow, that was a big one. All right, number 10. Is there a greatest common factor? No. All right, so leading 3 terms, leading coefficient equals 1, we're right here. We're looking for an A and an A, and then here we have negative 24. So that could be A. It's these guys up here. 1 and 24, 2 and 12, 3 and 8, 4 and 6, and one of them has to be negative. And let's see. These add to negative 23, doesn't quite make it. Negative 10, negative 5, and negative 2. None of these will add to a negative 21. That means this does not factor. It is just like a number that doesn't factor. It is called prime. All right, number 11. Okay, do we have a greatest common factor? Well, let me see. Not x's, because this doesn't have an x. This has 7's in it, and this has 12 times 12. There's no 7's in there, so no, there's no greatest common factor. 3 terms, the leading coefficient is not 1. Leading coefficient is 144. Okay, so, and I like this. Before you jump to the AC method, you could take 144 times 49, and you get something pretty doggone large out here. And that's okay, you can do it. And then if it's too large, start with the square roots and see if it works, and that'll work. But if you can identify that this is a perfect square, that's 12 squared, and that's 7 squared, then let's take a shot in the dark. I think it's 12x and a 7 squared like a binomial, and this is a plus sign in here. Let's double check. 12x times 12x, yes. 7 times 7, yes. The middle term has to be this times this doubled. 12x times 7 is 84. Doubled is 168. It worked. Look at how much work we saved. It could have been bigger than number 9. Holy cow. So if you'd like to see that out, you can see it's 12x plus 7 times 12x plus 7. And just the fact that you know that it will multiply and give you the 168, you don't have to go through a large process if you can identify that pattern. All right, next one. Number 12, 3p squared minus 363. Here's a great example of why we don't jump to see if it's a difference of squares or a difference of cubes, because 3 doesn't work and 363 doesn't work. Don't skip the first step. You've got to see if there's a greatest common factor first. So here we can pull out a 3 and we get p squared minus 121. Now, does this guy go down any further? Yeah, there's 2 terms. And it's subtraction of perfect squares. If you square root that guy and square root that guy, you get 11. So this is p minus 11, p plus 11. That's the pattern for a difference of squares. And there's that 3 sitting out front. All right, number 13. Okay, is there anything common? 16x to the 4th minus 81t to the 4th. This is 9 times 9, so it's got 3's and 9's in it. This is 4 times 4, so it has 4's and 2's and 8's in it. So nothing common there. Okay, so we have 2 terms. Is it a difference of squares or is it a sum or difference of cubes? Well, it's not a sum. It's got a minus sign. So is 16 a perfect square or a perfect cube? It's a perfect square. This is 4 times 4. So this is going to give us 4x squared. And the square root of this guy is 9t. 9t. So you got to have a plus and a minus there. 4x squared plus 9t, 4x squared minus 9t. Excellent. Good job. Now, each one of these, 9t squared, I apologize, 9t squared. We got to times up to t to the 4th. Now, let's write that just a little bit better. Okay, that looks better. Make sure those squareds are in those parentheses. Now, as we look at each of these factors that came out, each of them have 2 terms. This one would be a sum of, look, 4 and 9 are still perfect squares. 4 and 9 are still perfect squares. Notice that a difference of squares, this one, is still able to be factored. Sum of squares cannot be. So let's go ahead and factor this guy out. Square root of 4x squared, that's 2x. Square root of 9t squared is a 3t. So it's 2x plus 3t, 2x minus 3t. But remember, you can't do anything with that one. So that guy can't go anywhere. Yeah. So this is the answer. Difference of squares can keep going until you're not a perfect square anymore. Good. Number 14. 72x cubed minus 8x. 2 terms with a subtraction, but don't jump to that yet. Can you pull out the greatest common factor? Greatest common factor happens first. We can pull out an 8x, and we're left with 9x squared minus 1. And what's left? How many terms? 1, 2. So we're looking for a difference of squares or a sum or difference of cubes. It's a difference because this is subtraction of 9 is a perfect square. So it's a difference of squares that we're looking for. Square root of 9x squared is 3x. Square root of 1 is 1 plus and 3x minus 1. 1 positive, 1 negative. They are conjugates, if you remember that word. And then the 8x stays out in front. Great. All right, number 15. Pull out the greatest common factor first. Between an 8, a 24, and an 18. Oh, I'd love to pull out an 8, but 18 doesn't have an 8 in it. 8 and 24, and then, oh shoot, that's got 2 times 9 times 9. So just a 2 comes out of there. So we're left with 4x squared minus 12x plus 9. All right. Okay, so we now have 1, 2, 3 terms left. 3, leading coefficient, is not equal to 1. So let's check and see if it's a perfect square. Oh, 4 is a perfect square. 9 is a perfect square. Yeah, this could be, let me see, 2x times 2x and 3 times 3. And this is a minus sign. Does 2 times 3 doubled equal 12? Yeah, 2 times negative 3 is negative 6. Doubled is 12. We got it. We're all done. Now, if you were not able to see that, you could have done 4 times 9 was 36. Have 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6, and you realize it's a negative 6 and a negative 6, and you could actually split that and keep going with the AC method, and you would have gotten there just fine. You would have gotten a 2x minus 3 and a 2x minus 3. So you could have done that route, that's fine, if you weren't able to pick up that that was a perfect square and a perfect square, and then see that pattern of a perfect square trinomial. All right, and finally, the number 16. 1 minus 9z squared. Is there a greatest common factor first and foremost? None. No, there's not. You got a 1, 9z squared. So how many terms? 2. This is a subtraction sign, so it's a difference. Is it a difference of squares or a difference of cubes? And 9 is a perfect square. So we take the square root of each of them. Square root of 1 is 1. Square root of 9z squared is 3z. And one of them has to be a positive, one of them a negative to knock out all the middle terms. Difference of squares. And it's the same thing that we ended up doing up here on number 13 twice. And on number 12, we did the same thing. Good.